Okay, so this third lesson of the electricity unit is going to be covering 3 different types of charging. So 3 ways to charge objects. So it says here, charging is when a neutral object is given a charge, either positive or negative. So we know neutral, guys, is when an object has equal number of protons, positive charges, as electrons, negative charges. So when we charge something, this actually causes the neutral object to become either positively or negatively charged. This can be done in 3 different ways. The first way we're going to talk about is by friction. So this is rubbing 2 objects together. The second is by conduction. Okay, so this is by touching 2 objects together. And then this third way is by induction, which is not touching. Okay, so just bringing close together, but not actually making contact. Okay, so charging by friction, the transfer of electrons between neutral objects when they are rubbed together. So when 2 objects are rubbed together through friction, this actually causes electrons to transfer from one object to the other, which causes a change in the charge. It changes from being neutral to either positively or negatively charged. It says here, one object will give up electrons and become positive. The other will accept the electrons and become negative. Okay, so the object that's going to give away the electrons, that means it's giving away the negative charges, and it's ultimately going to have more positive charges. So that's why that object will become positively charged. The other will accept the electrons. Okay, so that object will have more negative charges, and because of that, it will ultimately become negatively charged. So if you look at the diagram down below here, we start off with 2 neutral objects. So we have this object here, 3 positives, 3 negatives, so that's neutral, right? They really just cancel each other out, those charges. And then we have this second object here. Okay. Oops. That was supposed to be yellow. So we have this second object here, same thing, neutral, because 3 positives and 3 negatives, 3 protons, 3 electrons cancel each other out. When you rub them together, okay, so we see here 2 objects being rubbed together, 2 neutral objects. Because of this charging by friction, electrons transfer. So it's important to know that it's not positives that are moving from one object to another, or protons. It's strictly just the electrons that move from one object or transfer from one to the other. So in this case, you'll see that we have the electrons moving from this material over to this material. Okay, so we'll see in future slides that some materials are likely to give up electrons and some are likely to accept. So in this case, this gray material here is going to give up electrons, and the orange material is going to gain the electrons. So they move from the gray object to the orange object. And now over here, you'll see that the orange object now has more negatives than positives. So we actually have 5 negatives and only 3 positives. So that gives the orange object ultimately a negative charge. And then the gray object here has less negatives than positives. It has more positives than negatives. So that's going to give it a positive charge. Okay, and then now these 2 objects are oppositely charged, so their opposites attract. There's going to be an attractive force between them. Okay, so what's charging by friction? Rubbing together, causing electrons to transfer from one object to the other. One picks the electrons up, making it negative. One loses the electrons, making it positive. Because again, it's going to now have more positives, protons, than negatives, the electrons. Okay, another example is shown here. So you'll see on the hair here and the comb, they're both neutral. Okay, they both have a neutral charge. Okay, it looks like for the most part, they have the same or equal number of protons and electrons. They are then rubbed together, and I can see here that the electrons have transferred from the hair to the comb. So the electrons moved from the hair to the comb. That means that the hair lost electrons to become positively charged, and the comb gains the electrons to become negatively charged. And again, opposites attract, so that's why we see this attractive force between the hair and the comb. Okay, so the second type of charging is charging by conduction. So it says here, producing or creating a charge through contact. Two objects with a different charge come in contact and electrons are transferred between them. So like in charging by friction, this was starting off with two neutral objects being rubbed together to produce a charge on both objects. Now we're seeing charge through contact, but just touching. And this is two objects with different charges and electrons being transferred. So if we look at this diagram down here, we have this two objects here, this metal rod here. Okay, we have seven electrons and 2 protons. So if we do our canceling out, that leaves 5 electrons. So we have a -5 charge, and then this metal block or rod, we'll say, is now touching this metal ball. Metal ball started out as neutral, so it looks like we have 4 protons and 4 electrons here. So we know those cancel out. We're left with a neutral charge. Okay, so that is a negatively charged object coming and touching, making contact with a neutral object. Remember, I've mentioned before that electrons are always going to be moving from the more negative object to the less negative object. So in this case, this rod here, or block, is the more negative object, right? We have a -5, 5 negatives, or 5 electrons, whereas the metal ball is neutral. So the electrons are always going to move from the more negative object to the less negative object. Neutral is less negative than the -5, so that's why electrons are going to move this way. Okay, so electrons are going to transfer from the metal block to the metal ball, and the whole reason is to even out the imbalance of charges, so to try to balance out the charges as best as possible. So this metal block is going to lose 2 electrons and is now going to have a -3 charge, and the metal ball is going to gain 2 electrons to have a -2 charge. Okay, so electrons are going to transfer from the more negative object to the less negative object when charging through conduction, which is charging through contact. Okay, to try to balance out the difference in charges between them. Lastly, we have charging by induction. This is producing a charge in a neutral object by bringing a charged object close to it. So we saw a little bit of this on our first lesson. Charging by induction is like creating this temporary charge on an object, but the actual electrons aren't necessarily moving from one object to the other. There's just a shift in electrons on the object. So if you look here, okay, we have this neutral metal sphere, and then over in the second diagram, this negatively charged rod is brought close to the neutral metal sphere. So because the rod is negatively charged, the positives or the protons are going to be attracted to those negatives because we know opposites attract. So the positives on the sphere are going to try to get as close as possible to the negatives on the rod. The negatives, or the electrons on the sphere, are going to try to get away or move as far away from the negatively charged rod as possible, because like charges repel. So this causes like a temporary positive charge on this side of the ball, a temporary negative charge on this side of the ball. So positive over here, negative over here. And this is just something temporary while that negatively charged rod is brought close to the sphere. Okay, you'll see in this third diagram over here, the negatively charged metal rod has been taken away, and all of those electrons have moved back to their regular position. Okay, so it's inducing a temporary charge, is changing the shift in electrons on the object until that object is taken away. Okay, so I'll just do highlight. Reducing a charge in a neutral object by bringing a charged object close to it. Okay, so triboelectric series or electrostatic series, these are interchangeable. This is a list of substances in order from a weaker hold on electrons to a stronger hold on electrons. Therefore, substances higher in the list always lose electrons to become positively charged. Okay, so losing electrons to become positively charged. And substances lower on the list gain electrons to become negatively charged. So guys, the electrostatic series is a list of different materials. The materials that are higher up on the list just have a tendency when rubbed with another object, so like charging through friction, when rubbed with another object, they just have the tendency to lose the electrons. So if they're going to lose and get rid of those negative charges, they're ultimately going to have more positive charges, making positively charged. Whereas substances lower on this list of materials have the tendency to gain electrons when rubbed with another material. So if this substance is gaining electrons, that's more negative charges, causing it to become negative charged. There are two factors that affect the amount of static charge. Number one is the amount of rubbing, okay, and number two is the ability of substances to hold on to electrons. So we're going to see an example of this electrostatic series. Okay, so here's an example here. So again, you'll notice that this is a list of materials. The materials higher on the list have the tendency to lose electrons. So if you're getting rid of electrons, that's getting rid of negative charges. So these guys are more likely to become positive, whereas as you go down on the list, okay, the materials lower have the tendency to gain electrons. So they have a stronger hold on the electrons when being rubbed with another material. So they're going to tend to be more negative. They're going to become negatively charged because they've gained more electrons, which are negatively charged. So just to do a quick example with you here, if you were to take, let's say, human hair, and rub human hair with an ebonite rod. Okay, so if you were to charge by friction, so rubbing human hair, human hair with ebonite. So human hair is higher on the list, so it has the tendency to lose electrons. So it has the weaker hold on electrons. So the electrons are going to move and transfer onto the ebonite rod because the ebonite rod is lower on the list, which means it has the stronger hold on electrons and it has the tendency to gain them. So the human hair is going to lose the electrons to become positively charged, and the ebonite rod is going to gain the electrons to become negatively charged. Okay, so if you were to rub human hair with ebonite, they would both start off as neutral. After the rubbing, human hair would lose electrons to become positively charged, and the ebonite rod would gain electrons to become negatively charged. Okay, higher up on the list, it's going to be positive. Lower on the list, it's going to be negative. Grounding. An object is grounded when it is connected to the earth through a connecting wire. If a charged conductor is grounded, it will become neutral. So we talked a little bit about grounding when we did the lightning lesson, because lightning rods help to ground the excess electricity. So remember, like different barn roofs or home roofs will have a metal rod because it's a good conductor of electricity, and when lightning strikes, it'll provide a safe path for electricity to flow down into the ground. So that would be an example of grounding. So you can ground an object by connecting it to the earth. Okay, how else does grounding occur? So when we touch a metal ball of positive charge, electrons flow from the earth to the metal ball to neutralize the metal ball. So again, it's always about minimizing this charge imbalance. So electrons are always going to move from the more negative object to the less negative object. So in this case, we have this, see here, this positively charged metal ball. So electrons are going to be attracted to those protons. So if this metal ball is connected to the earth through a grounding wire or through a person, if you go and touch this ball, the electrons are going to travel from the ground up and to the ball to balance out the charges. Okay, so this would be an example that electrons are moving from the ground up to the ball to neutralize it. Similarly, if the metal ball is of negative charge, okay, so you'll see in this case, we have a negative charged metal ball here now. Again, we want to even out the charges. So in order to remove some electrons, these extra electrons flow from the metal ball to the earth and the ball becomes neutral. So this would be an example of grounding. And again, if you have this positively charged metal ball, it's only the electrons that are doing the moving, so they will come down, move up from the ground to the ball to neutralize the ball, equal out the positives and negatives. And then similarly, if the ball is negatively charged, then those negatives are going to travel down into the ground again to equal out the positive and negative charges to make the ball neutral. So there's some different ways to detect static charges. Number one is a pith ball electroscope. Oops, wrong color. These are made up of a ball of pith, so this is usually plant material hanging by a thread. The ball is neutral. If the object is charged, the pith ball will attract to it. So by using a pith ball electroscope, this helps to determine whether an object is charged or not. So for example, if you have a object that, say, you bring it close and it's positively charged, okay, so overall it has a positive charge, and the pith ball is neutral, well, that's a neutral object coming close to a positive object. We know that opposite charges attract, so you would know that the metal rod was charged if you saw an attractive force between the objects. So the pith ball hanging by the thread would actually move towards the metal rod if the metal rod was actually charged, because opposites attract. Similarly, if you had a negatively charged rod, the same thing would happen. Okay, you know that an object is charged if there is an attractive force between the rod and the pith ball. So if we had negatives on here, the same thing would happen. We have a negatively charged object coming close to a neutral object that's still opposites attracting. So there would be like this attractive force between the two, and the ball hanging by the thread would move towards metal rod. Okay, if nothing happened, if there was no attractive force between the two, then that would tell you that the metal rod was neutral, because nothing happens between two neutral objects. And lastly, you can detect static charges by using the metal leaf electroscope. So we've talked a little bit about this so far. This is more sensitive to electrical charges than a pith ball. It is a thin rod with two metal pieces of foil. So at the bottom here, guys, there's two metal pieces of foil. If you bring an object near the top of the rod, this can help determine if the rod is charged or not. If the object is charged, the metal pieces will move apart. So if you were to bring a metal rod that's negatively charged close to this metal leaf electroscope, the metal ball, what would happen is all of the negatives that were on the metal ball would want to try to move as far away from the negatively charged metal rod as possible, because we know like charges repel. So the negatives that are on the ball would travel down and they would build up on the leaves. So a whole bunch of negatives at the bottom. And because now there's a whole bunch of negative charges at the bottom building up on the leaves, I'm just going to redraw this here, the leaves actually separate, because now there's a whole bunch of negatives on both leaves, and those leaves want to repel each other because like charges repel. So this is just another way to be able to determine if an object is charged. In this case, I've shown you that if you brought a negatively charged metal rod close to the metal leaf electroscope, the negatives on the electroscope would move as far away as possible, because like charges repel, they would build up on the bottom on the metal pieces of foil, and then those foils would separate because likes repel, and those negatives or those electrons would be trying to get as far away from each other as possible. Okay, and you guys have a little bit of practice on pages 10 to 12 in your booklet. Thanks, guys.